The Korean reactor KSTAR, a world leader in nuclear fusion research. Nuclear fusion is a process in which two light atomic nuclei fuse together to form a heavier nucleus and release a large amount of energy. This is the same process that powers the sun and stars. Nuclear fusion has the potential to provide clean, safe, and almost unlimited energy for humanity, but it also poses many technical and economic challenges to achieve it on Earth. One of the devices that aims to study and harness nuclear fusion is the Korean reactor KSTAR, Korea Superconducting Tokamak Advanced Research, also known as artificial sun. KSTAR is a magnetic fusion device that uses a donut-shaped chamber called Tokamak to confine and heat plasma, which is a state of matter formed by ions, atoms with electric charge, and free electrons. KSTAR is one of the first research tokamaks in the world to feature fully superconducting magnets, which allow for stronger and more stable magnetic fields than conventional magnets. Superconducting magnets are also more energy efficient and can operate for longer periods of time. This feature makes KSTAR relevant for ITER, International Thermonuclear Experimental Reactor, an international project that aims to build the world's largest tokamak and demonstrate that nuclear fusion can produce more energy than it consumes. KSTAR was built in 2007 by the Korea Institute of Fusion Energy, KFE, in collaboration with other national and international institutions. It is located in Daejeon, South Korea.